Alright, welcome back. Today we're going to be determining the quadratic functions given roots of parabolas. So essentially what we're going to be doing today is we're going to be solving the algebra backwards. So we're going to be given the end and we're going to have to go back to the beginning. So the way that I'm going to do this is by first identifying the solutions to this graph, the roots, the zeros, the x-intercepts, and that's going to be x equals -2 and x equals -5. Then what I'm going to do is I'm going to solve this in reverse by adding 2 to both sides, adding 5 to both sides. That's going to give me x plus 2 equals 0, x plus 5 equals 0. And now what I can do is multiply those back together. X plus 2 times x plus 5 equals 0. Do double distribution or FOIL. And I get x squared plus 5x plus 2x plus 10. And then combine like terms, and that is that. So, given a graph, find the roots, set them both equal to 0, and multiply them back together. Given two zeros, we simply do the same thing. However, when it's a fraction, we've got to deal with it a little bit differently. Because we don't want to have a fractional root, we're going to instead have a coefficient in front of the x. So with the first one, x equals -3/4, I'm going to first multiply both sides by 4. That's going to give me the coefficient in front of the x. 4x equals -3. So that's going to be 4x plus 3 equals 0. And then of course this one, x equals 2. That's x minus 2 equals 0. 4x plus 3 times x minus 2, and I'm going to double distribute or use FOIL. That's going to be 4x squared minus 8x plus 3x minus 6. I'm going to combine like terms, and that's going to give me 4x squared minus 5x minus 6. And that's my final answer. Moving on down to the next one, we are going to write the quadratic function in standard form that has an x-intercept at -6. So that's going to be x equals -6, x plus 6 equals 0. And because it's only one single x-intercept and it's a quadratic function, that's x plus 6 quantity squared equals 0. That's your perfect square trinomial. So there's a squared, that's b, plus 2 times a times b plus b squared. And there's your function in standard form. All right, now we're going to get into the imaginary solutions, and we'll talk about this a little bit differently. Instead of using factoring, we're going to instead use properties of squares, square roots to help us out here. Okay, so I'm going to go ahead and add the real part back to the other side of the equation, and that gives me x plus 2 equals plus or minus 3i. So in order to have gotten to this part from a quadratic function, I square rooted to get rid of this squared symbol in my prior problem. So now working backwards, I'm going to square both sides to get my quadratic function back again. So now it's going to be x plus 2 quantity squared equals 3 squared, which is 9, I squared, which is -1, and now I get x plus 2 quantity squared equals negative 9. I'm going to, at the same time, move these numbers and multiply out that perfect square trinomial. So a is x, so a squared plus 2 times a times b plus b squared. And that's going to be plus 9 equals 0. Just moving the 9 to the other side. So now I'm going to simplify by combining like terms, and I get x squared plus 4x plus 13 equals 0. Let's try this one again with a different type of problem so you can see it one more time. So notice that I've got a fraction. Remember, we're not going to have fractional parts of the roots. Instead, what we're going to do is we're just going to have a coefficient in front. Okay, so I'm going to multiply both sides. So let me write it out first. 1 plus or minus I root 5 divided by 2. Multiply both sides by 2. Now I get 2x equals 1 plus or minus I root 5. Now I'm going to move that 1 back to the other side using subtraction. 2x minus 1 equals plus or minus I root 5. Now if you remember, this was a quadratic when I solved it for its root, so that means that it has to become a quadratic again. So now that the complex part or the imaginary part of the number is isolated, now I'm going to go ahead and square both sides, and that's going to give me my quadratic back again, as well as remove the imaginary part from this particular equation. So I get 2x minus 1 quantity squared equals the square root of 5 squared, which is 5, and that's I squared, which is still negative 1. So now I'm going to multiply this out, and I get 4x squared, because remember a is 2x, so 2x squared is 4x squared, and that's going to be plus 2 times a times b, so that's going to be 4x. Let me fix that. That should not be plus. That should be minus. And then that's going to be plus 1. And then, of course, this equals negative 5. Move the 5 to the other side by using addition, and I get 4x squared minus 4x plus 6 equals 0 by adding 5 to both sides. And that is my solution in standard form. All right. The next three, what you're going to be given are sets of ordered pairs. And I want to go ahead and look at this so that you can see it and you can be clear about how it works. Okay, so we're going to find the quadratic equation with solutions 3 and 8. All right, so if I were to graph this, solutions 3 and 8 means that 1, 2, 3, 4, 5, 6, 7, 8. So there's 3 and there's 8. And then I've got a point 2, 3, which is somewhere on the graph 2, 1, 2, 3 here. So that means my parabola looks like this. And now I can solve this problem carefully. Now, you would think at first that all you needed to do was use the roots as your 2 points, and then you just go from there. But the problem here is that this tells me that that also has to be included, so I can't just automatically use the roots. I have to also include the points 2, 3. So because that third point must be included, I'm going to instead use the stat edit feature of my calculator. So let's open that up right now so you can see it. So I went ahead and put those 3 ordered pairs into the calculator. And now I'm going to go to Stat, Calculate. It's a quadratic, so I'm going to quadratic regression. And let's go ahead and calculate it. So that's going to give me 0.5 x squared minus 5.5x plus 12. And I still have my diagnostic tool on, so that's how I know that it's a perfect regression. So it's going to be y equals 1/2 x squared minus 11 halves x plus 12. All right, we're going to try that one more time. Please remember that when you do this with quadratic regression, you must always have 3 points. If you have 3 points, then you can use quadratic regression. If you don't, then you can't. All right, so the 3 points I've got here are negative 2/5, 0, negative 1, 30, and 0, negative 24. I'm going to use those 3 points, plug them into my stat edit feature, and then I will solve using quadratic regression one more time. So open up your calculator stat edit feature one more time. Once you hit negative 2/5 in and hit enter, it'll change it to the decimal form there. That's why it says negative 0.4. All right, so stat, calculate, quadratic, enter all the way through. And negative 10, negative 64, and negative 24 are your A, B, and C coefficients respectively. So y equals negative 10x squared minus 64x minus 24. Give you some different perspectives so you can see a different way of solving these problems. I'm going to solve number 8 by using matrices instead of stat edit features. All right, so notice what I've done here is I've left A, B, and C as unknown variables, and I've changed the variables x and y into the 3 known quantities in each one of the 3 equations of this system. Then what I've done is I've entered in an augmented matrix using those values, and that is where I'm going to begin the next portion of the calculator work. All right, I'll start my script, and then we'll get started. So go to your matrix, edit whichever matrix you've chosen. I've chosen matrix C. It's a 3 by 4. And write in your numbers from your augmented matrix. Notice how it's just overriding what's already there if you've already using one that you've used previously. Alright, quit out of your matrix so we don't insert one into another. Go back to the matrix screen. Go to your math. We're doing reduced row echelon format, so find that particular command. Retrieve your matrix. In my case, it's matrix C. And your augmented matrix is 3, negative 5, 1. The first position is A, the second position is B, and the third position is C. So that gives me an equation of y equals 3x squared minus 5x plus 1. So regardless of the way that you solve these problems, remember we're always solving them backwards. This time we're given solutions or points on the graph, and we're expected to write the equations from that. The best way to do that is working backwards through the algebra, or like you've noticed here in the last several problems, using matrices or stat edit regression lines to help you solve these problems.